Hello, so welcome to this video. In this video you are going to find the equation of two orthogonal lines. When they say orthogonal lines, these are perpendicular lines. They meet at 90 degrees. These same lines pass through this point, make an angle 45 with this other line. So the angle between two lines, tan theta, where theta is the angle between the lines, can be given as m2 minus m1 divided by 1 plus m1 m2. So we can find that angle by this expression, but now in this question the angle is given. So we have two lines making an angle 45 with this other line. So when we look at this line, let me call this given line as line 1. So the gradient m1 is 2, and when two angles are meeting when two lines are meeting a particular line at the same angle, it implies that one angle will meet it at 45 degrees and the other angle will meet it at negative 45 degrees. You need to note that if there are two different lines making an angle with a line, one should be at a negative angle, another at a positive angle. That is an idea. But so let us see when the angle is 45. Let us see the gradient of that line which makes an angle of 45. So that will be tan 45 equal to, I'll take m2 minus 2 divided by 1 plus 2m2. So tan 45 is 1. This is m2 minus 2 over 1 plus 2m2. So we shall get m2 minus 2 equal to 1 plus 2m2. Then put 1 this side, I get negative 2 minus negative 1 equal to 2m2 minus m2. So one of the lines will have a gradient of negative 3. But that line passes through this point, so you can find its equation by using y minus 2 over x minus 3 equal to negative 3. So this is going to give us y minus 2 equal to negative 3 plus 9 y, oh this is negative 3x, negative 3x plus 9. So this will be y plus 3x, then minus 2, bring negative 9 here, we get negative 11 equal to 0. Now to find the other line, since these two lines are orthogonal, we can just use the gradient of this line. There are two ways, or we can come back here and we use this angle. So let me use, since the two lines are orthogonal, so the gradient of another line will be equal to negative a third, and they pass through the same point. So that is if I don't want to come and I use the negative 45 so that I get its gradient. I know the lines are orthogonal, I can just have to use the gradient of this line, and this gradient, no, it is a third. If we rearrange it, it is a third. This is not, because this can be written as y equal to negative 3x plus 11 and negative 3 times m should give us a negative 1. So the gradient of the other line is when we take negative 3 times that gradient to get a negative 1. So the gradient will be a third. So let me clear this space here. Already I have this line. Now I need the second line. So if this is the gradient of the other line, then again I will come and I say y minus 2 over x minus 3, changing y over changing x is equal to the gradient of the other line, since they are perpendicular, is going to be a third. So this will be 3y, if I cross multiply, minus 6 equal to x minus 3, giving me 3y minus x minus 3 equal to 0. So this is the second line. How else can I find the gradient of this second line? I just come here. Since the other line, which had the gradient of negative 3, I used an angle 45, I can now come and I use tan negative 45. So this gives me negative 1. And when I get a negative 1, let me remove this. If we use tan negative 45, we shall get negative 1 equal to the gradient of that line is m minus 2, maintaining the same expression. By this time we use negative 45, so I get 1 plus 2m. Please, if we used m2 minus 2, don't take 2 minus m2. So you have to stick to the same expression. So here we are going now to cross multiply. We get m minus 2 equal to negative 1 negative 2m. So put negative 1 this side, I get negative 2 plus 1 equal to negative 2m minus m. So this will be negative 1 equal to negative 3m, and you can easily see that the gradient of that line is going to be a third, as we got it here. So there are two possible ways of finding the gradient of the other line. When you've been told that the lines are orthogonal, you have two options now. Once you get to one of the equations, the equation of one of the lines, you look at that gradient, multiply it with negative 1 and get the gradient of the other line, and remember they are passing through the same point. Or since since they are all making the same angle, that means if one line make an angle 45, the other one make an angle of negative 45. So you come back and you find the gradient from that angle which it makes with this other line, and you get that gradient. So there are two ways of finding the gradient of the other line. So I wish you success in your revision. Let us meet for other questions.